Okay, today it's about quadratic regression. It's 2.1.3, I believe. Anybody verify? Did we just do 2.1.2 last night? Okay, 2.1.3. Okay, good. So it's about quadratic regression. So what is that? That's taking data like this, 2, 3, 4, 5, and instead of making a linear regression, which you guys are already familiar with, these are my x's, these will be my y's, I'm going to do a quadratic regression. Okay? I'm going to make the simplest one in the world. 2 squared would be 4, 3 squared would be 9, 4 squared would be 16, 5 squared would be 25. Do you get how that's quadratic growth as compared to linear, which would have been something like this? 1, 2, 3, 4 goes with 6, 7, 8, 9. It just grows a little bit each time. This, over the course of just a few numbers, is growing a lot. Okay, it's getting from 4 all the way up to 25. That's a lot faster growth. So then you'd probably suspect that your data isn't linear, it's quadratic. Could it also be cubic data? Yeah, that happens too. Quadratic and linear are the two most popular. All right, so how do we put this in the calculator? Well, first of all, get those numbers on the left here into your calculator in the list. And I'm going to pause for a second while I do that. Okay, I'll show you where it is. In the calculator here, I'm going under Stat and Edit, and it'll edit my lists. I'm going to go into my L1 and put in my 2, 3, 4, and 5. I already made a mistake. 2, enter. 3, enter. 4, enter. 5, enter. Okay, and then over here, we're going to put in 4, 9, 16, 25. 4, 9, 16, 25. Okay. Any questions on the data? Okay, good. Now everybody hit Stat. And what do you think we want to do? Yes, sir? Calculate. So arrow over to calculate. Number 5, quadratic. You are correct, because this is quadratic data. You see how there's cubic and quartic right underneath it? Those are the next levels. That's x to the third and x to the fourth. But we're doing number 5, quadratic. Hit enter. Now, on my calculator, it says this. For a lot of you, it doesn't. Now, my calculator's got the newest operating system on it now. So how many of you have a calculator that looks like this now? All right, and that's less than half of the class. I'll tell you verbally what you other guys should do. The other people, you should be typing in L1, L2, Y1. But on the new operating system, they already have the L1 and the L2. Frequency list, I don't need that. I can skip right over it. And I'm going to store my regression equation under Y1. So other people with the older operating system, you type in L1, L2, Y1. I'm now going to put in my Y1, and here's how you do that. The Y1 is under vars, yvars, function, Y1. Okay. Now, if it fails right now, as I go to calculate, the other people would just hit enter. If it fails right now, it's probably because there's something on my Y1. If yours crashed, it's probably because there already was an equation on your Y1. So you can check that by going over here to your y equals and seeing if it put the equation in like it was supposed to. See, there's the equation. Y equals 1x squared plus 0x plus 0. It's kind of a fancy way of just saying x squared, isn't it? And I did do the most simple of all quadratics, so that was just x squared. Most of the time, your data is going to actually have numbers there, and that are much bigger, like 2.46x squared plus 9.78x plus 1.937 or whatever. All right. So how do you use it? Well, you guys are smart enough to be able to just look at this chart and say, if I say that x is 6, you could just do it in your head, couldn't you? What is it? 36. But how would we do that on the calculator? Because the numbers aren't going to be that nice. How do I figure out x is 6? I put it in the table. Everybody go to second table. And you find on the table where the spot is that you want. I wanted 6. So I go up to x is 6, and I go over here, and it says 36. All right, I'm going to give you a tougher one. What if x was 6.2? Do you know how to change your table? If you don't, then watch. If you do know how, go ahead and do it. I want to know, what if x is 6.2? All right, for those that don't know, go to table settings. It's right above window. And you start at 0 is fine. Actually, though, if we're going to count by 0.1s, maybe we should start more like at 6 and then count by 0.1s. 0.1. That's the triangle table means change table. All right? Don't ever mess with the independent and dependent. Just let them be automatic. Then, where am I going now? Table. My table should look different. Yeah, look at that. It goes by 0.1s. If you started your table at 0, you just have to arrow down a lot. I just knew that if I was going to go for 6.2, I may as well start at 6. All right, so there we go. 6.2, 38.44. Make sense? Okay, what if I had said, I want to know when this thing first hits 46. Just to clarify, when the y value would be 46. So I can just go over here and go, well, there's 46. There's 46. So when did it first hit 46? Would you agree it's somewhere between 6.7 and 6.8? So maybe we should have this thing count even more carefully and start at 6.7 and go by 0.05s, for instance. Okay, so I'm going to go to my table settings, have it start at 6.7, and count by 0.05s. Now I'm going to go back to my table and see how it looks. There we go. That's better. And the first time it hits 45 is right between 6.7 and 6.75. Now, we're not going to need you to be any more accurate than that. But all right. So there's your basics of doing quadratic regressions. So you're going to give you a bunch of data. You put it in the thing. You do lin, or you can do the process. Second, calculate. Stat calculate a quadrag and L1, L2, Y1, or if you have the new operating system, you put the Y1 right there. You get your equation, and then from there it's just trying to figure out how to use that data on the chart. Okay, I would probably use your chart pretty exclusively for that. So if this had been like year, and this had been how many cats you had in your house. There are cat hoarders out there. You've all seen the crazy cat lady. They exist in real life. So if by year 5 she's got 25 cats, now she's starting to lose control. And all of a sudden there's cats like having other cats all over the place, and like, oh my gosh, pretty soon. We could say, when is she going to hit 100 cats? And you could go search your table until y becomes 100. And then if you really need to get more accurate, you can change your table settings to count by different things and stuff. Get the idea? All right, so that's your homework for today. And that leaves us about enough time we can take that top 20 test. Your homework is short and sweet, so I think you'll like it. It is worksheet 2.1.3. Last question? Individual questions, so I'll stop the video then.